Okay, so we're going to be talking about complex numbers, kind of part two here, and we're going to talk about the powers of I a little bit more. So last time we really only cared that I was the square root of -1, which made I squared the real number -1. So there's actually more powers of I to think about. If you have I cubed, you're really multiplying this first box, I, times this second box, I squared. Well, I times -1 is -I. And if you're thinking about I to the fourth, isn't that just I squared times I squared? And -1 times -1 is 1. So when you go further than these four boxes, it's kind of like a circle repeating itself. So if you wanted to evaluate I to the fifth or I to the sixth, you're really thinking about I to the fourth plus kind of a remainder of I, because 4 plus 1 is a power of 5. I to the fourth, I squared, that adds up to 6. I to the fourth is just 1, so it's like the identity. So really, this is going to behave just like I to the first. This is going to behave just like I squared. So I to the first, second, third, and fourth, I to the fifth, sixth, seventh, and eighth, I to the ninth, 10th, 11th, 12th. Anytime you've got a fourth power, so I to the fourth, 8th, 12th, 16th, I to the fourth times I to the fourth times I to the fourth is just 1 times 1 times 1 times 1. So if it's a divisible power by 4, the answer is just 1. So here are four examples where we are going to reduce the power of I down to one of these four answers. So I to the eighth, 8 is divisible by 4. So really, this is just I to the fourth times I to the fourth. And we know that 1 times 1 is just 1. I to the 17th. Well, what's divisible by 4? I to the 16th is divisible by 4. So this would just be I to the fourth, I to the fourth, I to the fourth, I to the fourth, or 1 times 1 times 1 times 1, which is 1. So the only kind of important part of this is the remainder. 16 plus 1 is 17. So this is going to behave just like the variable I. I to the 30th. So what's divisible by 4? I to the 28th is divisible by 4, and you'd have kind of 2 remaining to get to 30. So this is like the identity of multiplying by 1. So this is going to behave like I squared. And we know that I squared is -1. And I to the 27th, I to the 24th is what would be divisible by 4. 24 is divisible by 4, so you'd kind of have a remainder of 3. I to the 24th is just 1 times 1, 6 times. So I cubed is -I. So a little bit separate idea is reducing radicals using complex numbers. And I want to take you back to maybe your trig class when you had to reduce the square root of 8. You had to think of a perfect square and a non-perfect square that multiplied to give you 8. Then you had to take the square root of each of those parts independently. So the square root of 8 is equivalent to 2 root 2. Or if I took the square root of, say, 18, 18 is 9 times 2, or 3 root 2. What about the number 200? 200 is 100 times 2, or 10 root 2. These are always coming out to 2 for some reason, but they don't always come out that way. What about -4? -4 is really 4 times -1. I can take the square root of 4. I just can't take the square root of -4. If I take the square root of 4, I just get 2. If I take the square root of -1, I get I. So the square root of -4 is positive 2I. Same thing over here. I can take the square root of 100, and I can take the square root of -1 separately and get 10I. So for all of these, it's just going to be the square root of the number, I. So 5I, 8I, Now 40 is different because 40 needs a reduced radical. So let's see, 40 is 4 times 10 times -1. So take the square root of each of those things independently. 2 root 10i. I already did the square root of 200 by accident over here. So it would be 10 root 2i. And the I does not go under the radical. So I'm going to do the odd examples on the back page and just remind you of some of the strategies you learned last year on how to solve a quadratic. They're going to have some complex answers. And then I'm going to have you try 2, 4, and 6 to send me as your assignment for Google Classroom to get credit for today. So the first strategy is taking square roots. So the strategy for taking square roots is you want to get x squared by itself on the left side of the problem. So your first step would just be, let's divide by -4 on both sides. All right, now let's take the square root of both sides. X has to be equal to plus or minus, because when you take the square root, x could be, for example, if you had x squared was 9, x could either be 3 or -3 for solutions. So x is going to be positive or negative 2i, because the square root of 4 is 2, and the square root of -1 is I. So my two solutions would be positive or negative 2i. So in example 2, you're going to get x squared by itself by moving things to the other side, and then you're going to take the square root of both sides. Completing the square. So completing the square is a strategy where you move your c term to the other side. So I'm going to subtract 5 to the other side and leave myself some room here. You need to add 1/2 of the b value squared. So half of b is -1, and I'm going to square -1 and get +1. Whatever I add to one side of the equation, I add to the other side of the equation. And I'm going to write this as a perfect square trinomial. X minus 1 times x minus 1 is x minus 1 squared. And then I can take the square root of both sides of the equation, just like I did up here. So x minus 1 is equal to plus or minus 2i. How am I going to get that -1 to the other side? I'm going to add it. So x is actually equal to 1 plus or minus 2i, because you always want to leave it in standard form, a plus bi. All right, and so the last is the quadratic formula. So if you don't have that memorized, it's that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A in this case is 1, B is 2, and C is 5. And it has to be equal to 0 to use the quadratic formula, which it is. So I'm going to do the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. 4 minus 20 is -16. So I have -16 under the radical. Usually I would say no solution. The square root of -16 is 4i. So this is really -2 plus or minus 4i divided by 2. And I could really divide both terms by 2. So -1 plus or minus 2i is my final answer. And now you're going to go back and try those 3 examples, 2, 4, and 6, and send me a picture. Thanks.